Hi, my name's Tim, and before I get started, I want to let everyone know that I'm not trying to be condescending toward people who believe there is a flat Earth or a possibility of that. But I just want to let you know that unfortunately, you're not educated. Um, because if you were educated and you really knew something about mathematics and physics, you would understand that that would be completely impossible. Um, How do I know it's impossible? Well, intuitively, let's look at it this way. If you were on a merry-go-round, okay, we all agree that there's a daytime and a nighttime, correct? If you were rotating around the sun like this all the time, there would be no nighttime because the sun would refract, and if we were on a flat Earth, the sun would refract. Let's suppose that the sun is vertical and we are flat, just to try to make it realistic. Um, that wouldn't make sense because if I looked at it like that, then what would be holding the sun up? Okay. Would the sun be rotating this way and would be rotating this way? Is that what you're thinking? Okay. What about um, on the other side of the sun? It's still going to be sun. It's fusion, nuclear fusion. So we're going to have nuclear fusion all the way around the sun. Okay. So that means there would be no nighttime. Okay. That's one argument. The other argument is that centripetal force has been proved. It's an inward force. There's an equation for it, by the way. So that's been proved mathematically, and you can do it with vector analysis. For example, you got a position vector, and you have a basis I and j vectors with length 1. Okay, to find the x coordinate, if you plot a circle to find the x coordinate, would be r cosine omega t I plus r sine omega t j, and then you would get the vector r, position vector r. And then if you take the directional derivative, which is really just the tangential velocity, you would get the magnitude of the tangential velocity in terms of angular velocity. If you take a second derivative and you take the magnitude, you're going to get v squared over r, which is the tangential velocity squared divided by the radius. Okay, that would give you the centripetal acceleration of that circle. Okay, now if we were on a circle, another argument is if we're on this circle and we're going around the sun, okay, let's say that it flips, the circle flips to create nighttime. Once the circle flipped over, we would fall off because centripetal force would only be directed inward toward the center of that circle. Okay, so that doesn't make sense. All right, that's one argument. That's kind of an intuitive way of looking at it. Another argument I have is that many years ago, there was a scientist, Galileo, who built a telescope. He used the idea of refraction of light to build a telescope. He used meniscus lenses, the eyepiece and the objective has an eyepiece and objective. And he built this really remarkable telescope where he could actually see that there is mountains on the moon. And after he did that, he became, he decided that Copernicus is right. We do live in a heliocentric solar system, that the Earth rotates around the sun and all the planets rotate around the sun. So that was proved. Um, in addition to that, he observed the planets and he observed that they were spheres. Calculation wise, he used shadows to produce arcs on the Earth and trigonometry to show that they were arcs. And the only thing that's going to produce an arc like that is going to be a sphere. That's another thing he did. And then many years later, along came Isaac Newton, who used vector calculus to show that there's a force of attraction between spheres, not circles. It only works for spheres. He used vector calculus, and he proved that the equation for the force of attraction states that the force is directly proportional to the masses, the product of the masses between two planets, and the square of the distance between them from center to center. That, my friends, is Isaac Newton. Okay. He knew that that proportionality worked uh, as far as an equation, but he didn't have a value for G. Well, that's where Henry Cavendish came along in the 18th century, and he actually built a device that would measure the force of attraction of a small sphere circling around a large sphere. And he actually built a meter that would measure that force of attraction. Okay. So he was able to determine the value of G, the proportionality constant, which we now know as the universal gravitation constant. He was able to find a number for that, and that number is 6.67 times 10 to the minus 11 meters squared per kilogram squared times newtons. Okay. And that universal constant, when you multiply by the product of the masses divided by the square of the distance between those two masses, everything cancels but newtons, so you get a force. Okay, that's what that equation is based upon. Cavendish actually calculated the value of G, okay, which I think is ingenious. I rarely hear about that in history. I don't know why, but the man was an absolute genius. Okay. Um, so Cavendish, he tried the experiment with discs first, and it didn't work. He said it's not possible to do it like that. So he used spheres, and he was able to do it. He was able to create a model and actually measure that gravitational constant, which was a giant leap for science. Okay, so that proves it. Um, so I mean, I'm not being condescending. I'm not calling somebody stupid if they think there's a flat Earth. But what I am going to say is that it's absurd to think that because there's no math behind it. For one thing, if you come up with a verbal argument and you cannot substantiate that verbal argument, you cannot back that verbal argument up with mathematics, then it's not true. There's nothing I'm going to believe about our physical world to be true unless there is mathematics that can back it up. Okay. And there's no math that can back that up. It would not work. Mathematically, it would not work. Okay. If you flip a disc, everything's going to fall off. I mean, even if you're spinning that disc, if there's something on top and the centripetal force is holding that object in, if that disc flips over, the object is still it's gonna fly off. And if something is at the edge of that circular disc that's rotating, uh, centripetal force holds it in this way. Tangential force holds it in, you know, to makes it want to go straight. That's tangential velocity. And the vector sum of the two is called a resultant force that would make it, if it were going fast enough, make it fly off and at an angle. Okay, so and you can use, like I said, vector calculus to derive the formula for centripetal force using a basis. You start out with a basis, I and j vectors, and then you use trigonometry and come up with the directional derivative, which is the tangential velocity, and then you take the derivative of the tangential velocity and find the magnitude of that, and that will give you the formula v squared over r. V being the tangential velocity, and r being the radius from the center to a point on the circumference of that circle. Okay, this is mathematics. So, looking at this intelligently and showing that there's math to back up what I'm saying, I can actually use mathematics to prove that it would be impossible for our planet to be flat, for Earth to be flat. That is absurd. So, if you have an argument and you want to leave a comment, leave a comment. But before you leave that comment, I want you to also know that I'm not going to believe anything you say unless you can show me some equations that will back up what you're saying. You have to be able to prove this to me mathematically. And if you cannot, then I'm not going to believe you. Well, I wouldn't believe you. I know I'm not going to believe you because there's no such thing as a flat Earth. That's been, it's been proved that we live in a solar system that is comprised by spheres. Okay, not perfect spheres, but still spherically shaped planets. Okay, so that's just the way it is. I apologize if you think I'm trying to be condescending. I'm not trying to be condescending. I'm not calling anyone stupid here. I'm just saying that it is illogical to believe that there is, a flat Earth. There's no such thing as a flat Earth. The physics and the observations by many, 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 many astronomers and scientists and great people from the past just completely disproves the possibility of a flat Earth altogether. There's no way that could be possible. Okay. So if you learn the math, get yourself, if you really want to find out for yourself and do your own experiments, learn the math, get yourself a telescope and observe the planets and do the math. And you'll understand that it's impossible. It's impossible for us to be living on a flat Earth. That is not true. Okay? So there's no such thing as a flat Earth. We live on a spherical Earth, and all the planets that we revolve, the solar system, everything that revolves around everything in a solar system is spherical. Okay, so I hope this helps you. To kind of think about what I'm saying here, and maybe do some research on your own, and edification, man. You get the education and learn, some math and physics for yourself, and buy yourself some equipment if you have the money. Purchase yourself a really nice telescope and do some experiment yourself. Okay. All you would really need is, you don't really need vector calculus to do those experiments. Just, you could learn up to trigonometry, and you could probably do it with trigonometry and prove that we live on a world that's spherical. Unfortunately, I do know vector calculus, and I know for a fact that it's completely absurd to believe that there's a flat Earth. There's no such thing as a flat Earth. That would be impossible. Our Earth is spherical. Okay, so thank you for watching my video. Like I said, I'm not trying to be condescending. I'm not calling anybody stupid, but I'm using logic to show you that it's impossible for our Earth to be flat. There's no math that you could show me that would substantiate what you're saying. And if you don't have the math to back you up, then it's just absurd. It makes no sense. Okay? So thank you for watching my video. And remember, our Earth is a ball.